Saturn V Quarterly Film Report Number 10 covers progress during the period March, April, May 1965. Development, manufacturing, and testing of S-1C stage components by the Boeing Company and the Marshall Center continued throughout the quarter. Following installation of the S-1CT static firing stage on March 1st in Marshall's new S-1C static test stand, structural load testing of the vehicle's thrust structure was successfully performed. Propellant load testing of the S-1CT was then conducted in preparation for its initial firing. Installation of the stage's 5 F-1 engines, completed on March 30th, was accomplished in 3 days. On April 10th, approximately 2 months ahead of schedule, a 16-second static test of the S-1CT center engine was successfully conducted with no major problems encountered. 2 attempts on the previous day had failed to meet test requirements. After an analysis of performance data from the single engine firing, a decision was made to test all 5 F-1 engines. On April 16th, a Saturn V program major milestone was attained with a fully successful 5-engine static firing for a duration of 6.5 seconds. Total thrust of 7.5 million pounds was developed. Over 1,000 measurements of the S-1CT's performance were made and recorded in the blockhouse, located some 800 feet from the test stand. A second successful 5-engine firing was held on May 6th, this time for 15 seconds. On May 20th, a 40-second test was conducted, during which the 4 outboard engines were gimbaled. Early next quarter, a 1.5-minute test is scheduled, and then a 2.5-minute, or full-duration, static firing. In Marshall's load test tower, testing of the fuel tank thrust structure assembly for the S-1CS structural test stage was begun this quarter. The tests performed to date have been successful. Testing will continue for the next several months. The S-1CS LOX tank was completed March 11th and placed in storage for future structural testing. Assembly of S-1C1, the first flight stage, moved steadily toward completion. After the fuel tank and thrust structure were mated in the VAB, the unit was transferred to the horizontal assembly area. Following completion of the intertank LOX tank forward skirt assembly, slated for June, horizontal mating of the 2 units will be accomplished. Fabrication and assembly of S-1C2, the second flight stage, included completion and mating of the fuel tank halves, plus completion of LOX tank bulkheads. At Marshall's Michoud operations in New Orleans, the Boeing Company continued with its assembly of the dynamic test stage, S-1CD, the first S-1C stage to be manufactured there. In March, the S-1CD thrust structure was installed in Michoud's newly operational vertical assembly building. Following completion of fuel tank hydrostatic testing, vertical assembly of the S-1CD continued with stacking of the fuel tank and the intertank on the thrust structure. The 4 helium bottles for pressurizing the fuel tank were installed in the LOX tank in April. The LOX tank was assembled on April 18th in the VAB with mating of the lower and upper halves. During the quarter, Boeing continued work on S-1CF, facilities checkout stage, and began assembly of S-1C2, the first flight stage to be built at Michoud with initial bulkhead welding. At Michoud's new stage test facility, computer and telemetry equipment have been installed in the support section. The equipment will be used to obtain and evaluate information from the various S1C systems being tested under simulated flight conditions. The first S2 stage 5-engine cluster ignition test was successfully conducted on April 24th at Santa Susana Field Laboratory. The 5-second test consisted of battleship LH-2 tank preconditioning, loading of propellants to prescribed levels, preconditioning of engines and related systems, and performing the engine start sequence through the ignition phase. A prime test objective was verification of the proper sequence of J2 engine cluster operation. All test objectives were successfully achieved. On May 1st, a 10-second cluster main stage test was attempted, but was terminated prematurely after 1 second. An ignition-detected signal was not received from the number 3 engine, and cutoff occurred automatically. On May 7th at Santa Susana, a completely successful 10-second cluster firing of the 5 J2 engines of the battleship stage marked the attainment of a major program milestone by the S2 prime contractor, North American Aviation Space and Information Systems Division. Test objectives included preconditioning of the battleship LH-2 tank, the engines, and related systems. Structural testing of the S2SD Structural Test Dynamic Test Stage got underway on March 22nd with engine thrust load tests on the thrust structure. Upon completion of this series of tests, body load tests will be conducted. At S&ID's Seal Beach facility, the S2 Common Bulkhead Test Tank was successfully hydrostat tested in March and returned to the Vertical Assembly Building, where assembly was completed on May 26th. The CBTT was then shipped to Santa Susana, where the test program is scheduled to begin next quarter. A major milestone was reached with completion of structural buildup of the All Systems stage at the Seal Beach Vertical Assembly Building on May 26th. High-pressure pneumatic testing of the LH-2 and LOX tanks was completed next day, and the stage was transferred to Station 2 for systems installation. The S2F thrust structure this quarter became the first completed major subassembly for the facility's checkout stage. Structural assembly was begun on April 5th. Fabrication and assembly of the first S2 flight stage, S2-1, continued this quarter with the initial insulation bonding operation on LH-2 tank cylinder number 4. Fabrication of the common bulkhead and assembly of the quarter panels for the thrust structure. In S&ID's electromechanical mock-up control room at Downey, S2 stage automatic checkout equipment installation is now complete, and stage and GSE integration is being accomplished. GSE and stage integration in the local control mode was completed on April 29th. Development testing of the 8 solid propellant ullage rocket motors, which will be mounted on the S2 interstage structure, is underway at Rocketdyne's McGregor, Texas facility. During Saturn V flights, these motors will be fired simultaneously at the instant the S1C stage's engines are shut down. The S4B facility's checkout stage, which was installed in beta test stand number 3 at Douglas Aircraft Company's Sacramento test facility late last quarter, underwent successful propellant loading tests in both manual and semi-automatic modes during this report period. It was the first loading of cryogenic propellants into a flight type S4B with more than 100 tons of liquid hydrogen at minus 423 degrees Fahrenheit and liquid oxygen at 297 degrees being pumped into the stage. Workability of test stand equipment and compatibility of stage and stand were proved out successfully by the tests. Also at SACTO, the S-4B battleship test program continued this quarter in beta test stand number 1. With the completion of Saturn I-B development firings in mid-May, the battleship stage is being equipped with a Saturn V configuration J2 engine, and Saturn V testing will begin next quarter. Construction of the vertical checkout lab progressed during the report period, with erection of structural steel being accomplished. At Douglas's Huntington Beach plant, joining of the liquid oxygen and liquid hydrogen tanks for the S-4B 501, the first Saturn V flight stage, was completed, and the stage was hydrostatically tested. The stage was then moved into the cleaning tower for cleaning operations prior to installation of propellant tank insulation. Fabrication and assembly of components for S-4B 502, the second Saturn V flight stage, moved steadily ahead. Qualification testing of stage components, such as this umbilical disconnect, continued at Santa Monica. At Air Research's test facility in Phoenix, Arizona, qualification testing of the fuel feed duct was conducted by the Douglas subcontractor. Structural testing, such as this LOX tank water pressure test, was also underway at Douglas's Space Systems Center at Huntington Beach. At the Marshall Center, the first J2 engine to be delivered there by Rocketdyne was installed in the newly completed S-4B battleship test stand in April. Initial static firings will be for the Saturn I-B program. The stand will be used later for the Saturn V program. As part of its F-1 engine casting quality control program, Rocketdyne is now employing the high-energy X-ray service of the Southern California Cancer Center. The 2 million volt X-ray machine, used for cancer diagnosis and treatment during the day, is utilized in the evening for radiography of F-1 engine cast components. High-energy X-ray inspection has several advantages over conventional methods, including deep penetration of up to 12 inches of steel equivalent, greater scope of penetration, and a sensitivity which permits 1% difference in metal density to be read. By the end of April, thermal insulation had been installed on engine number 14-1 at Edwards Field Laboratory. Extended hold tests were then conducted by dropping LOX and fuel to the main propellant valves and monitoring ambient air temperatures and component skin temperatures inside the cocoon. Several fabricated electrical interface panels were built and tested during the quarter. These panels are constructed of machined parts and formed sheet metal parts bolted together. The testing procedure was similar to that used on the cast version. Preliminary analysis of test data indicates that the fabricated panel is structurally adequate for maximum flight loads. A teardown display for engineering examination and inspection of engine number 2006 at Rocketdyne's Canoga Park plant marked formal completion of the flight rating test phase of the F-1 program. The engine had been static fired in the FRT calibration series at Edwards. At the Marshall Center, the first F-1 engine for the first S-1C flight stage was delivered by Rocketdyne in March and is now undergoing minor modification work. The first J2 engine liquid oxygen turbo pump to be assembled at Rocketdyne's Neosho, Missouri plant was completed in March. Transfer of this component fabrication operation to Neosho was made to take advantage of manufacturing facilities there and to relieve the workload in the turbo machinery area at Rocketdyne's Canoga Park, California plant. After calibration of the Neosho facility's newly operational balancing machine, temporary balancing of the J2 LOX impeller was accomplished using beeswax weights. Metal is later removed from the impeller at points opposite to the weights to produce a balanced component. The last of 5 J2 engines for various phases of the S-4B battleship test program was delivered to Douglas, Sacramento on May 1st. This engine, which is of the Saturn V flight vehicle configuration, possesses a restart capability. A total of 6 successful malfunction tests were performed at Santa Susana this quarter as part of requirements for the J2 flight rating test program. The engine was deliberately fired with various malfunctions to determine the effect on performance and to see if a safe shutdown could be accomplished. FRT engine number 2023 was acceptance tested and the formal FRT program was begun in May, following electrical and mechanical checkout of the engine on the stand. FRT will be completed by June 30th. Vertical Test Stand 3A, which is equipped to simulate altitude conditions, was reactivated with this initial static firing in March after completion of modifications. Assembly continued at Marshall on the Flight Systems Instrument Unit 500FS. This is the first Saturn V IU in which all instrumentation will be actual working hardware. Meanwhile, the facility's checkout unit 500F is in storage and will be shipped to Cape Kennedy in August. Structural fabrication of the Saturn V Vibration Test Unit 500V is virtually complete, and component assembly will be finished next quarter. Assembly of the Saturn V IU Breadboard Test Unit SIU 500ST is continuing. SIU 200-500S, a structural test unit common to both the Saturn 1B and 5 programs, was installed atop an S4B forward skirt for structural testing, which got underway May 27th. A second IU structure, designated SIU 200-500S2, using segments manufactured by North American Aviation, will be assembled by IBM and tested to qualify the structures for Saturn V IUs and SIU 203 and subsequent. The first S2-124M stabilized platform for the IU was delivered to Marshall by the manufacturer Bendix Corporation in March and is undergoing checkout by MSFC personnel. The first Aerospace Systems Test and Evaluation Console, known as Aztec, for laboratory checkout of the IU digital computer and data adapter, was also delivered to Marshall by IBM Owego, New York. A significant development milestone, this marks successful completion of an overall systems marriage of the launch vehicle digital computer and data adapter and the systems test equipment. Checkout of the Integrated Automatic Checkout Telemetry Ground Station was performed by IBM Huntsville during the report period. This system is capable of receiving, recording, processing, and analyzing data transmitted by the various telemetry links of the Saturn vehicles and IUs. Milling of the mounting frame for the IU's ST-124M stabilized platform was also performed by IBM this quarter. At the Huntsville facility, work began in April on Building Number 5, to be used for administrative and engineering offices. IBM this quarter was awarded a contract for integration and checkout of IUs, in addition to its previous responsibility for design and manufacturing. The first of 24 ground computer systems from RCA Data Systems Division, Van Nuys, California, has been delivered to the Marshall Center. The system, known as the RCA 110A, was installed in Marshall's S1C stage checkout facility, which is now in process of build-up. Boeing Company personnel will operate the facility. Marshall's new Saturn V system development facility, also known as the Saturn V breadboard, began to take shape late in the quarter with initial installation of equipment, including 110A computers from RCA and a digital command system from Radiation Incorporated of Palm Bay, Florida. The Saturn V breadboard, being built up in Marshall's Quality and Reliability Assurance Lab, will be operated by Boeing. Upon completion, the Saturn V breadboard will appear like this tabletop scale model. In addition to various stage simulation equipment, the facility will contain such vehicle hardware as an F1 engine, S4B stage aft section with J2 engine, and S4B forward skirt with instrument unit attached. At Marshall's Mississippi Test Facility, construction progressed steadily this quarter on the test complex's two S2 stage static test stands and the dual position S1C stage static test stand, as well as on the associated facilities in MTF's laboratory and engineering complex and support services complex. An activation task force was also at work at MTF to help provide an orderly transition from construction and equipment installation to operational capability as various facilities are completed. Delivery of the S2 stages for testing at MTF has been rescheduled, with the S2T all systems due to be the first instead of the facility's checkout stage. The S2T, a multi-purpose ground test stage slated for delivery in September, will allow full duration static firing capability, providing additional data prior to firing S2-1. The change also allows more expeditious use of S2T ground support equipment, relieving an S&ID manufacturing problem. In summary, March, April, and May 1965 witnessed substantial achievement along a diverse front, with ground support equipment being integrated into the program in increasing volume. Various ground test instrument units in final stages of completion. Continuing advances in engine development, testing, and production. Successful S4B stage propellant loading tests and continuing flight stage assembly operations. A successful 5-engine cluster static firing of the S2 battleship stage. Concluding phases of assembly work on the first S1C flight stage. And the successful firing of all 5 engines of the S1C static test stage.